So we are going to be doing quantum physics. Let me read the question and then we'll do this together. Considering a particle of mass mu and energy E encountering a delta function barrier given by V of r is equal to g delta function of x minus a, where g is a positive real constant. A. Determine the continuity condition on psi prime. B. Using the above result, derive an expression for the reflection coefficient of the above case. So we'll sketch showing the regions. That is the first thing we'll do. We sketch showing the regions. So this is region 1, this is region 2. At this junction, x is equal to what? A. And then we have what information do we, at this point v is equal to 0. Here v also is equal to 0. But we are given that v of r is equal to g x minus a. So to determine the continuity condition on psi prime, we are going to be using this Kronecker equation. I hope you still remember the formula. Okay, so we have minus h cross square all over 2m. I hope you are seeing this square psi the x square plus v psi is equal to what? E psi. So this equation you are seeing, we are going to be integrating from a point before A to a point after A. So what I'm saying is that we're going to be integrating this equation. Let's call this equation 1, this Kronecker equation, equation 1. So we integrate from a point before A to a point after A. So let me wipe the beginning of the question. So if we integrate this, we have this from a point before A is minus 1 to a point after A is plus A. So we have the square psi all over the x square dx plus v minus A to plus A. Then we have v psi dx is equal to, from a point minus A to a point plus A, we have E psi dx. I hope you can see every information. So let's further break it down. So if we further break this down, we come up with, we have this minus h cross square over 2m. We have the psi dx, right, then plus, we'll substitute this v here. If we substitute, we'll bring out this, okay, this will be out of it. Then we have g, okay, into this, we have psi x, we've substituted this, right? So we have brought out this, so we'll be left with this, right? We'll be left with this. So we have dx minus a, and then we have equal to psi dx. It's okay. Let me add this, the before and the after. Okay, so remember we want to determine the continuity condition on psi 1. That's the question, the first question. So we will further break it down. We have this, okay, the psi dx, a plus a minus, then we have g is equal to, we have this e psi dx, Okay, permit me, I'll wipe this question. When we get to this junction, I'll read the question again. So let me wipe so that we can have space to solve. I'll read the question again from my notes. So we have this. So we say let E is equal to df dx. Okay, if we make E is equal to df dx, I mean psi, not E, psi. Let's make psi is equal to what? Df dx. So we'll substitute this into this, the right hand side, which is this. So if we substitute to the right hand side, we'll have this psi dx minus a to plus a from a point before a to a point after a. So we have this is equal to minus a. We substitute psi, we have e df dx. Okay, dx. Okay, so I will wipe this too. I'm not going to wipe this Schrödinger equation because we'll refer to it later. So we have this, right? So this becomes this. We have e df, okay, minus a plus a. This becomes e into f a plus minus f into a minus. Okay, so from what we have, it means that f is continuous. Okay, it implies that f is what? Continuous. And because it is continuous, this is going to be what? Equal to what? 0. So if we substitute this into this equation, let's call this equation 2, this equation 3, and this equation 4. If you substitute this, it means that everything here is equal to 0 because f is continuous, and because it is continuous, it is going to be 0. It means equation 4 will now be equal to minus h cross square over 2m, okay, dx, d psi dx, okay, a plus a minus plus g psi of a is equal to what? 0. So if we take this to the other side, if we take this one to the other side, it will become, sorry, this one we go at this junction, this one we go and it becomes just this. So if we take this to the other side, it becomes minus, let me wipe this. When I need to refer to this, I will take it from my notes. So this equation becomes what? We have minus h cross square over, no, sorry, it becomes d psi dx is equal to, this minus will go, because if you take this one to the other side, it becomes minus g psi of a. Okay, so the minus will cancel each other. All right, then we have, should I just do it one step at a time? Let me break it down step by step. So we have minus h cross, we have minus h cross squared over 2m, okay, the psi dx, this is psi please, a plus a minus is equal to minus g psi of a. Okay, so this minus will cancel this minus. Okay, now we will multiply both sides by 2m over h cross. I don't know if you can see my blue marker. So we'll multiply both sides by what? 2m all over h cross. If we multiply both sides by 2m over h cross, okay, this, we agree that this has cancelled, this minus has cancelled. So let's multiply both sides by 2m over h cross squared. If you are doing this in your book, it means you have to go to the next step. It is because I'm doing it on the board, okay, to save space. Then we have times what? 2m over what? H cross. This will cancel this. This will cancel this. And then we'll be left with this, right? So it means we'll have the psi over the x, a minus a cross is equal to 2m. If I bring this to this side, it will now be 2mg psi a all over what? H cross squared. Okay, remember we're looking for the continuity condition on psi prime. Okay, so I wipe the upper part. So if I do this, if I wipe the upper part, I'll have this. If I wipe the other upper part, it means this is going to be equal to what? The psi dx of a plus minus the psi dx of a minus, okay, is equal to 2mg all over h cross squared psi of a. All right, I hope you know this. The psi dx is the same thing as this prime, and then we have our a plus minus the psi dx is the same thing as what? Sine prime, and then we have what? A minus, a minus, okay, is equal to 2mg h cross squared psi of what? A. Okay, so now this is the continuity condition on psi prime. This is the what? This is the answer. This is the continuity condition on psi prime. We are going to be doing the part 2 in the next video. All right, bye.